Hi everybody, welcome from HVACR Design Engineering. I am Tuyao. Now I want to talk about bar using air conditioning and refrigeration system. Handbar are installed to permit easy isolation of system, but this makes it possible to perform many types of repair without loss of refrigerant. Diaphragm type handbar are used for smaller copper tube, while ball and club bar are used for larger tubing. An arrow on the bar indicates the direction of refrigerant flow. Handbar location. Handbar can be used to isolate and evacuate portion of the system. They are often used to permit easy changing of filter dryer. A crankcase pressure regulator (CPR) is an outlet pressure regulator. Its primary purpose is to prevent excess pressure from entering the compressor. Excess suction pressure often occurs at started or after a defrost cycle. High suction pressure causes high discharge pressure and the compressor may run on the overload. Short cycling causes loss of oil from the compressor crankcase and possible trip out on the pressure safety control. Crankcase pressure regulator CPR system. The CPR is adjusted by turning a screw located under the cover cap. When making adjustment, the low pressure gauge should be installed on the cable. Most refrigeration CPR are set to limit leaving suction pressure to 18 to 20 psi. The CPR provides the compressor time to get the suction pressure under control below 20 psi. Head pressure control bar. Head pressure control bar is non-adjustable. Head pressure control bar automatically maintains a minimum head pressure during cold ambient. When head pressure drops to the set point, the bar allows hot gas to bypass the condenser and go directly to the receiver. Head pressure control bar will bypass enough hot gas to maintain the minimum head pressure. Evaporator pressure regulator. Purpose of evaporator pressure regulator is to prevent evaporator pressure from falling below the value support. It is used to prevent evaporator freeze-up to temperature system and multiple evaporator. The evaporator pressure regulator is fully adjustable and can be installed anywhere in the section line. To adjust an EPR bar, remove the cap and turn the adjustment screw with the proper side head wrench. A pressure gauge should be attached to the cold bar port to observe the effect of any adjustment. Make minor adjustment and allow time for the system to stabilize. Evaporator pressure regulator EPR system. A typical application for an EPR is to prevent evaporator freeze-up. For air conditioning, the EPR is set to keep the evaporator pressure from dropping below 45 psi in R22 system. The purpose of evaporator EPR is to prevent the evaporator pressure from dropping below the value supply. 2. Temperature system. In this temperature system, the freezer is the primary system and dairy cooler is secondary. And EPR, evaporator pressure regulator, is required on the dairy cooler section line and set for 68 psig. EPR prevented dairy cooler from getting cooler than 32 degrees Fahrenheit. A check bar is required in the freezer section line to prevent dairy cooler from vapor entering the freezer hot to go. The system pressure control is set to control the freezer. Multiplex evaporator. Multiplex evaporator refers to a system having more than one evaporator. Each evaporator has its own evaporator pressure regulator EPR to permit individual temperature control. Any number of evaporators can be connected to a single compressor and individually connected by EPR. Multiplex compressor. Multiplex compressor system overcome problems associated with a single leg compressor. Each compressor is cycled on and off as needed by individual pressure control. If one compressor fails, the system continues to operate with the remaining compressor. Solenoid valve. Solenoid valve are either open or closed. When electricity is not flowing to the coil, plunger is in the down position, blocking flow. When electricity is flowing to the coil is energizing, creating an electromagnetic field that lifts the plunger and the bar is open. Automated burn-down cycle. The burn-down cycle is popular because it solves many problems. Burn-down in a refrigeration circuit is a great way to avoid liquid migration back to the compressor on-off cycle. Burn-down means sending refrigerant in low pressure side to high pressure side. Low pressure side is from outlet of thermostatic expansion bar to the compressor inlet. High pressure side is from compressor outlet to thermostatic expansion bar. As startup, the thermostat close to energize the solenoid valve. The refrigerant flow to the evaporator and section pressure rise, and then the pressure control start the compressor. At shutdown, the thermostat open and the solenoid valve close to stop refrigerant flow. The compressor continue to run, and then the low pressure side is reduced to about 1 psig. This removes all refrigerant while flowing the low pressure side of the system before shutdown. Hot gas bypass. Hot gas bypass is a method of making a large system keep running when the heat load is reduced. Large system must make provision for operation during reduced load condition to maintain temperature and humidity control. A practical solution is to bypass a small portion of hot discharge gas directly in the low pressure side. Hot gas only bypass when section pressure is reduced to the bar supply. This method places a forced load on the evaporator to maintain minimum operation. Desuperheating thermostatic expansion valve (TEV). Hot gas is often bypassed to the suction line downstream for the evaporator. This bypass gas must be desuperheated before entering the compressor. The desuperheating thermostatic expansion valve (TEV) or liquid injection valve is used to supply enough liquid refrigerant to cool the bypass gas down to 10 degree Fahrenheit to 20 degree Fahrenheit of superheat. Centrifugal chiller. This is a cutaway view of 510 centrifugal chiller with 3 compression state of volume. Chiller evaporator. The proper level of liquid refrigerant in the evaporator is to just cover the water tube. Chiller system. Cutaway view of water-cooled chiller system with reciprocating type compressor is shown in the figure. Open loop. When an open loop travel from condenser to the cooling tower, the water is open to the atmosphere inside the cooling tower, hence its name. Closed loop. Water traveling to and from the air handler is called the closed loop. The chi water travel to the cooling coil inside the air duct to absorb heat. The water loop is not returned to the chiller evaporator to be recooled. Two-pipe system. A two-pipe chiller system may have one larger air handler or individual air handler located in different areas. The two-pipe system pump cold chiller water in the summer and hot boiler water in the winter. Four-pipe system. In the four-pipe chiller system, air handling units are located in areas that require individual heating, cooling, or humidity control at all times. Heat pump. The heat pump is an air conditioning system capable of reversing the refrigerant flow to function as a heating source. Thus, the autocoil absorbs heat from the ambient air and discharges this heat into the hole via the indoor coil. Reversing valve operation. The system thermostat controls the reversing valve coil, which determines the direction of refrigerant flow. The reversing valve coil may be energized during the cooling or heating mode, depending on the manufacturer. Movement of the piston is performed by the system pressure controlled by the valve coil. Heat pump thermostatic expansion valve (TEV). The older heat pump system used two thermostatic expansion valve (TEV) and bypass line with chuck valve. One chuck valve is bypassing refrigerant along the TEV. The other chuck valve prevents bypass. This illustration shows the cooling cycle only. Heat pump capillary tube. A capillary tube will meter in either direction. A feeder dryer is normally placed at each entry to the capillary tube. There are two types of filter dryer. Liquid line type is placed after the condenser coil and before the expansion bar. The liquid refrigerant that flows from the condenser to the expansion bar is filtered from particles and moisture before entering it. Suction line type is placed after the evaporator and before the compressor. This device is used to protect the compressor, especially after any failure that contaminate the system. Check valve and bypass are not needed. The drawing shows the heating cycle only. Thank you very much for watching my video.